Hello, welcome to Creature Study, where we look at fictional creatures anatomy and their ecosystem to understand how they have evolved. In this episode we inspect the Hornetaur from the Monster Hunter series, but this episode is limited specifically to the ones found in Monster Hunter World. The reason I picked this one for this episode is that according to the Monster Hunter World fandom page, the original Japanese classification for the Hornetaur is Kabutoshimoshi Shu, which translates to beetle species, which in contemporary taxonology would classify it as a Coleoptera, which is Greek for seeth wing. But there are noticeable discrepancies in the classification and how they look, and the more I looked into it, the more interesting they became. So we will look at how similar to beetles they really are. Hornetaurs can be found in the Rotten Vale, where they have the ecological role as predators and detritivores living in a mutualistic relationship with the bigger monsters, such as the Radoban. The Radoban will bring large meaty prey back to its nest, where the Hornetaur acts out their ecological role as detritivores by eating the remains of the carcasses, which prevent potentially harmful organisms from immigrating, as well as preventing growth of diseases and bacteria which could be harmful for the Radoban and its offspring living in the nest. In return, the Hornetaur gets easy access to food. The Hornetaur appears to be living in concentrated underground colonies, and it is unclear to which degree they share the food and spaces among themselves, rather than fighting each other out of the tunnels and fighting for their food resources. By being a type of burrowing beetle, although not a very able one, it is sort of implied that the Hornetaur is an altruistic species, where the altruistic nature of the burrowing beetles leads them to have a strong parental instinct and will stand by and feed their larvae after hatching. They appear in large numbers in their habitats, and being altruistic and caretaking of their own species in this manner could play a big part as to how they are able to have such a high natality rate and grow their colonies so big. We could also note how Hornetaurs can affect the community as a whole. Because of their high natality rate and their concentrated populations, they could rapidly outgrow other populations in their communities. And we must also note their very aggressive behavior in attacking other populations of the same community. So, while they may have some intraspecific competition in their colonies, they surely have strong interspecific competition with other populations of their same communities. Considering the competitive exclusion principle, which states that no two species living in the same space can have identical ecological requirements, one will always outcompete the other, we can consider them as a major density dependency factor for other species in the community, where the Hornetaur's instincts leading them to have a high natality rate means less food for the other species of the community, which are dependent on the same resources, causing these populations to shrink due to starvation. Because we can find the Hornetaur in many locations through the game series, we can consider them as a contender as a pioneering species, meaning they are among the first organisms to extend to new habitats. However, because of being carnivorous detritivores, they are dependent on prey and leftovers from other predators to survive. We can see that they have the potential to grow into massive colonies, but their reliance on other species is an obvious limiting factor for where they can successfully immigrate to. If they immigrate alone to a new territory, they will shortly die off because of starvation. Considering their natality rate, they probably grow into colonies quickly, and when they start starving, they emigrate to new territories. And since it is likely to happen rapidly, they emigrate often, and therefore they are a widespread species through the world of Monster Hunter. As a broad overview, we can see the typical insect structures. We can start with the most obvious part of the beetle classification, which is the wings. A beetle is classified by having elytra, so instead of having 4 functional wings, a beetle will have 2 hardened forewings called elytra, which covers over the 2 hind wings as a means of protecting them. Though there are some agreement in literature that also the elytra have some function in flight, such as balancing or even assisting in flight. The Hornetaur appears to have 4 functioning wings for flight, a pair of forewings and hindwings coming from the meso and metathorax. So that does not quite fit the classification for beetles, but it may be a good fit for the classification for a Orthoptera, whose forewings will have a much more active role in flight. These wings are called tegmen, and can be recognized by its softer tissue and veins. If we isolate the prothorax and the head, we can compare the Hornetaur to a rhinoceros beetle by its long horn ascending from the prothorax and the head. The horns may be used for digging, but the beetles who are better developed for digging, like the burrowing beetles and many scat beetles, have shorter spoon-shaped plate structures on their head and protrusions along their plates, as well as the front and back legs to help with the digging. Looking at the abdomen, on its ventral side we can see a clear aposematic coloration. There is a general agreement in literature that insects do not see the color red, so this stripe of red color is not for other insects, but insects may use these recognizable colored patterns as a means of warning off predators. Insects which have these markings also tend to be poisonous to eat, or at least have a foul taste, and this is helpful for certain predators to recognize their species and avoid eating them again after an initial poor experience. Another recognizable feature of the Hornetaur is their long cerci, which you won't see on beetles. In insects that do possess them, they tend to serve many different roles among the different species. Some use them to hold prey or mates, and some use them as sensory organs, and in some insects they are just vestigial organs. Cerci of this size is more common for the Orthoptera order. It is hard to determine whether we are seeing male or female Hornetaurs, but we are most likely seeing one of these sexes through the game unless they are sexually monomorphic. However, this is uncommon among insects, especially beetles, where the sexes are often distinguishable in structures or size or colors. Female rhinoceros beetles have no horns at all, and neither can we see signs of an ovipositor, which is used by the female to lay ova. We can put it this way: either the Hornetaurs are sexually monomorphic, or they have certain instincts which leads the females to stay on the ground for various reasons. For instance, for tending to the ova or larvae. Lastly, we can look at its legs, where we see that the metathoracic femur rises above the abdomen. This is more common, again, for the Orthoptera, which uses this posture as a mean for momentum for jumping, for instance. A beetle will commonly have its leg appendages extending under its abdomen, and often have a shorter femur or equally short tibia and tarsus, though there are exceptions such as the tiger beetle. So the beetle classification of the Hornetaur does not add up in most of the cases, and I really hope that the classification was not just a translation error listed on the fandom page, because that would make this, the focus of this video, pretty pointless, but otherwise it was fun observing and learning about it.